Hey, it's Mr. Luneski. Today we are looking at Unit 5, Section 2. We are now going to be looking at ways to prove that two triangles are congruent, or ways to prove that two triangles are the same. Our methods that we are going to be looking at today are SSS and SAS, also known as Side-Side-Side and Sideangleside Congruency. So let's take a look at what these are all about. So the rest of this unit, we're going to be looking at ways to prove that two triangles are congruent. So what exactly does it mean for triangles to be congruent? Essentially that means that the measures of the sides and that the measures of the angles are all going to be congruent. So imagine that you had two pieces of cardboard cut out into triangles and you're kind of rearranging them in such a way that you could stack them on top of each other and they would match exactly. So you could kind of flip them, you could rotate them, and you just want to get the triangles to match. And that's sort of what we're doing with the rest of this unit, is trying to get the triangles to match. When we figure out how the triangles match, we can write what is called a congruency statement. Basically saying triangle blah is congruent to triangle blah. So in this example here, everything on the figure is marked. So these little arches here signify angles being congruent, and then the little tick marks here indicate sides being congruent. Now notice kind of how they change. It's 1 tick mark, 2 tick marks, 3 tick marks. So that means that this side here matches with this side here. Also this angle and this angle we can call sort of a match, that those match each other, and then this angle where there's 2 lines and this angle where there's 2 lines is also a match. And then our last one is this. So when I write my congruency statement, I always want the parts to match each other. So for instance, I would say triangle LMN is congruent, and now here's where I want the parts to match. Is congruent to triangle, so what matched with L? L matched with R. What matched with M? M matched with T. And what matched with N? N matched with S. So that would be my congruency statement where everything matched each other. Now, is that the only way we could have written this particular congruency statement? No. Another way we could have written this is we could have said triangle NML is congruent to triangle STR. Keeping in mind that N has to match up with S, M has to match up with T, and L has to match up with R. And you can write that in any order that you want. So another example would have been MNL is congruent to triangle TSR. So these are just a couple of ways that we could write that. Did we have to start with triangle LMN? No, we could have started with triangle RST. Really doesn't matter. So those are congruency statements, and we're going to be seeing quite a bit of those the rest of the unit here. Last class we talked about how the angles of the triangles always add up to 180 degrees. So there's a little theorem that pulls from that called the third angles theorem, or third angle theorem. What this says is if two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. In other words, this is 35, that's 35. This is 88, that's 88. So by default, this angle here has to be congruent to that angle there. And if you think about this logically, 180 minus 88 minus 35, that's going to equal 57 degrees. So both of these angles would both be 57 degrees. So if I were to write a congruency statement on these two triangles, I would say something like triangle ABC is congruent to triangle HIJ, because A matches with H, B matches with I, C matches with J. So there are actually 5 ways to prove that two triangles are congruent, that two triangles are the same. In this particular section, we are only going to be looking at 2 of those ways, and then in the next section, we're going to look at the rest of the ways. So So the first way that we're going to prove triangles are congruent is called side-side-side congruency. So what this basically says is that if two triangles are congruent, if all three sides of one triangle are congruent to the corresponding sides of another triangle. In other words, if I can see clearly that all three sides are congruent, then I can say, hey, these two triangles are the same. So in this particular problem, if we look, we have 1, 2, and 3 little marks here. So I kind of want to match it in that sense. If I'm going sort of 1, 2, 3, when I go around this triangle, it would be 1, 2, 3. So I want to go in that order. So I'll say A to B to C is congruent to D to E to F. So in this problem, we can say that triangle ABC is congruent to triangle DEF because of side-side-side congruency, because all three sides are the same. So I want you to remember that the triangles may not look like they're congruent, but you're allowed to rotate and you're allowed to flip the triangles in such a way that you can sort of get them to match up. So they might not always look like they're the same orientation. But if I essentially take this triangle here and sort of flip it over like a pancake, then it would match that triangle. The next way to prove two triangles are congruent is with side-angle-side congruency. So when we look at that, what we are saying is that triangles are congruent if any pair of corresponding sides and their included angle are equal in both triangles. So the big question is, what is the included angle? The included angle is essentially the angle that's in between the two sides. So notice how I have this side and this side marked congruent. This would be considered the included angle. These two sides are marked congruent. This is the included angle. So in this particular figure, once again, we want the orientation to be the same, making sure that the parts match up. So once again, I can say in this one that triangle ABC is congruent to DEF. And that would be because of side-angle-side congruency. So those are the two ways that we're going to look at today, side-side-side and side-angle-side. So here are some examples now where the triangles are not separated. So what we had just looked at were just two separated triangles with everything marked, and that's not exciting. That's not what it's going to look like. We're going to be looking at examples here where the triangles are sort of pushed together or twisted in a kind of a weird way, and now we need to be able to figure out, well, how can I prove these two triangles congruent? So I'm going to give you some hints and tips and things to look out for when we're doing these types of problems. So how would we prove these triangles congruent? So if we take a look, we have a side and we have sides here. So these sides are equal and these sides here are equal. So now basically we have side-side-side or side-angle-side. So if I take a look, there's nothing I can say about any of these angles. I don't know that this is a bisector. I don't know that these are equal just because they might look like they are. I can't make that claim. But what I can say is that if I cover up this triangle here, it has line UD. And if I cover up this triangle here also has line UD. So they have what's called a shared side. And so I can mark that side congruent to itself. And that would be side, side, side. So again, this is called a shared side. So you always want to look out for shared sides. In this next one, we have a side and a side that match. We have another side and another side that match. And now in this one, I can't say anything about this side just because it looks like they might be the same length. I can't assume that. But what I can say is that this angle would be congruent to this angle because they're vertical. So you want to look out for vertical angles as well, because we always know that vertical angles are congruent. So how would I prove these two triangles are congruent? I would prove them congruent using side-angle-side congruency. And then this last one here, we have a side and a side that match up. We have an angle and an angle that match up. And once again, these two triangles are pushed on top of each other, and they share this side right here. So this is my second side, or my second congruency. So once again, that one would be side angles side. All right. So down here it says things to look out for. So throughout the rest of this chapter, I'm going to be giving you little hints on things to kind of keep an eye out for. So one of the things that we had just talked about was shared sides, saying that something is equal to itself. So we're also going to be still looking at proofs in this unit. I know, hold back your excitement. Where we can say, well, if we have a shared side, that would be a reflexive property. And we can also say that vertical angles are congruent or equal to themselves because of the vertical angle congruency theorem. All right, so we are, to finish this up, we're going to look at two examples of proofs here. In this unit, you will be responsible for filling in your own proof, meaning the statements and the reasons. We're not going to be filling in the statements for you as much anymore. So you have to kind of logically piece that together yourself. So we're going to practice that, though. Use the figures. Mark them, because that's going to really help you visually see what the heck is going on here. So what are we given here? We are given that AC is congruent to AB. So go ahead and mark that. AC is congruent to AB. We're also told that AD is bisecting CV. So this line right here is bisecting this line. It's cutting it in half. So, like every proof, we always get to start with our givens. So AC congruent to AB, that's given to me. So what I'm going to do is I'm going to put a star next to that, because what we essentially want in these triangle proofs is to look for three congruencies of either sides or angles. So as I go through the proofs, I'm going to put a star next to my congruencies, and once I get all three stars, I can say, oh, time to prove the triangle congruent, because that's what we're trying to prove. Prove that triangle ADC, that this triangle here, is the same as this triangle here. So I already know that that's going to be my last step. So I can kind of fill that in. That looks like another triangle. Okay. So my next given is that AD bisects CB. Why do I know that? That's also given to me. So remember our hint that we're using a vocab word, bisect. So what does it mean to bisect? Well, if AD is bisecting CB, that means that these two pieces here, CD and BD, are going to be congruent. Why? Because it's bisecting. Definition of bisector. So here I can say that CD is congruent to BD, and that's a definition of a bisector. And I can put a star next to that, because now I have a second congruency. So 1, 2. So now I need that third congruency. So right now we have side, 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 or side, angle, side. Can't say anything about any of these angles. Don't really know anything about that just yet. But I can say that this is a shared side. So I can say AD is congruent to AD due to the reflexive property. And so now based on this, I can say, hey, that's congruent because of side, side, side congruency. Now, there are multiple ways of solving different proofs, so notice that was my third congruency, so now I can finish it off. Okay, and let's take a look at this last proof here. So once again, we're going to start by marking our figure. AB is congruent to DB. So AB is here, DB is here. CB is congruent to EB. Now notice what I'm going to do with my markings. Instead of using one tick mark, I'm going to use two tick marks because I'm moving on to the next congruency. And so now let's start our proof here. AB congruent to DB. That's given to me, and hey, that's one congruency. So put a star. CB congruent to EB. Once again, that's given to me, and hey, that's a second congruency. So what do I have right now? I have side and side. So now I either need the third side or I need an angle. I need this included angle. Well, I can't say anything about the sides, but I know from my little hint list that those are vertical angles, and I can say vertical angles are congruent. So that's what I'm going to use. That's my angle, and I'll use side angle side. So now to finish this thing off, we're going to say that angle ABE is congruent to angle CBD. That's my third congruency, and that's the vertical angle congruence theorem. So again, ABE, CBD. And remember, this will always be your last step. So triangle ABE is congruent to triangle DBC. And what did we use to solve that? We used Sideangleside Congruency, the old SAS. Alright, that is it for this video. Thank you for watching.